Hey there kids, welcome to another math video. This is for grade 5, Eureka Math, Module 4, Lesson 14, homework. And as always, go watch the problem set video before this so you can know what you're doing and finish your homework, or at least give it a try. The thinking process is really, really important, and you should be thinking about it and doing it and trying it before you actually go through this with me. This is really just a checking process and to set you straight if you had any problems on your homework. The objective is at the bottom of the page: multiply unit fractions by non-unit fractions. So we've got ones times twos or fours. So there's always going to be a one. They're trying to ease you into the whole multiplying fractions process. But multiplying fractions is really fun and easy. It's like multiply across the top, multiply across the bottom, simplify if you can, and you're done. So I love multiplying with fractions, always have. It just seems really easy. So today we're going to solve. We're also going to draw a rectangular fraction model to explain your thinking. So here we go. The first thing, not my favorite, honestly, like how many times should we say this to ourselves? 1/2 of 2/3 equals 1/2 of what? 2/3. So we're just kind of repeating ourselves here, and then we're going to draw the model in order to get the answer. So when you draw your model, remember that it's the second fraction that exists first. So we're going to take half of what we had in the beginning. In the beginning, you have 2/3. So the second fraction is being modeled with the vertical picture, okay? Then you're going to take half of that. Whatever you take, that first number, the half of, that's going to be your horizontal part of the model, okay? So your 6 squares should be in rows this way, like 2 rows of 3, if you do your model correctly. So now we're going to do our opposite shading, because we're going to take half of that. It doesn't matter if you do the top or the bottom. It does not matter, because either way, you're only going to have the crisscrossing on 2 or in 2 of these pieces there. I'll even put that little line there so you can see that we have 2. So the 1/2 of 2/3, if you want to write it over here, I'm going to show you something else. Okay, so I have my 1 times 2 is 2, and my 2 times 3 is 6. I have 2 pieces out of 3, 4, 5, 6. That's where they're getting the 6 total number of pieces, and then we have 2 here. But that's not giving you the wording that they have here. So what do you do with this? You should recognize that, hey, I can do something else with it. Mrs. Setness's rules for simplifying fractions. Rule 2 is all even numbers are divisible by 2, so do it. Divide by 2. When you do that, sometimes I'll write it and sometimes I don't. I'll say, okay, divide both the top and the bottom by the same number. 2 divided by 2 is 1. 6 divided by 2 is 3. And now you have your 1/3 that is the final answer. Now, why does that work, and where is this 1/3 coming from? I'll show you. If the 2 boxes were there for the pink, then I'm going to make 3 boxes here, noticing that this one box here is still with the double crisscross. That is 1 out of 3 with blue. Okay, so equivalent fractions, like that's what it is. It's equivalent. 1 out of 3 of these size pieces is actually the same as 2 out of 6 of these pieces. It's the same thing. They are equal. And that's what we're trying to have you guys notice and figure out with these models today. Now, with cross-canceling from a couple lessons ago, if you were to take 1/2 times 2/3, and you do the cross-canceling before you multiply it, you would see that in the commutative property, you switch the places and you have 2 over 2 to give you 1. you end up with 1/3 on your first go. Okay, so I know that's probably, I just lost a few kids there. They're scratching their heads like, what? So I won't be setting it up like this so much as I will be setting it up with the cross canceling. That's where we're going. You have to know how to do that. Okay, second one with the super wordy, annoying double equal signs to try to figure this out. It's 1/2 of 4/3. So this time I have thirds, but I have more than 1. 4/3 means, let's make our 4/3. There's 3/3. Here's my 4th third. So let's shade those. And the 4th third. Okay, that's 4/3. 1/3, 1/3, 1/3, 1/3. 1, 2, 3, 4. There it is. Okay, now we're going to take half of that. Half of 4/3. The half is what you take here. Take it all the way across so that you now have the proper number of pieces, which we now have 6ths. So I'm going to write that over here. I'm going to write my whole problem 1/2 times 4/3. Now you might want to rewrite it if it makes you feel comfortable to switch and use the commutative property on just the bottom numbers. Okay, yes, you could just switch the top. It does not matter, but I'm comfortable switching the bottom. That's what I do most of the time. And so now that I've switched those bottom numbers, you see that you have this fraction here, 4 divided by 2, and you get 2. It's really 2 over 1. The 1 just multiplies by 3, and it doesn't have any difference. So then we have 1 times 2 is 2, and 3 times 1 is 3. And so your final answer is going to be 2/3. I haven't done my double crisscrossing yet, so I'm going to go back to my model, finish that out. And again, we have our simplified answer here. If you don't simplify and you do your 1/2 times 4/3, this is where you're going to see the 4/6. 1, 2, 3, 4. Out of the whole that would be 6. Kids will say, what about 12? Well, it's really, we're talking about how many are in 1. So it was going to be either 3/3, but it's also 6/6 because that just means 1. How many pieces are in 1? Okay. So we have our answer. 2/3 is the answer. Go ahead and circle that. And we don't need to have 4/6 because they really want you to get the simplified form. Hopefully you know what you're doing now because we're going to go a little bit faster. Okay, we're going to do 3/5 for our model. 1, 2, 3, 4, 5. We're going to shade 3. We're going to take 1/3 of that, so we need thirds going across. Shade the opposite direction. If you want to rewrite, you can. If you have tiny little writing, you can use this. I usually just rewrite it because I kind of like to write big, and I like to move things around. And I want to show you that when you have 3, if I was to switch it around, I would end up with 1. And so I do this with the cross canceling because nobody wants to have to rewrite it like this all the time. So you just leave it alone, cross these out, make it the 1, and then continue multiplying. Now, why is it 1/5? Well, because if I was going to identify with my colored marker where we have the double crisscross, I can make a total of 5 of these pieces. Okay, if we have 3 in each one, okay, there'd be 1 here, 2, 3, 4, 5. And we're really just talking about 1 out of 5. So that's why the equivalence work. Kind of went over that in A. Let's keep going. 1/5 is the answer here. And again, we're really just interested in the simplified version. So if you're still getting 3/15, that's not the point of the lesson. Yes, you're successful multiplying, but that's the difference between like a 3 and a 4. All right, so half of 6/8. I have to have 6/8. So I need to make first fourths, then eighths. And we're going to shade 6 of them. 3, 4, 5, 6. You can just kind of scribble. It doesn't really matter. It's not art class, it's math class. So 6/8 are now shaded, and we're going to take half of that. And the shading for this one would go the opposite direction. And so this section right here is where the answer lives. But that's going to be all the pieces. And we don't have to have so many pieces when we simplify. So with this one, when you look to cross cancel, use the 2 as your divisor. If I was going to switch places, it would be 6/2. Well, 6 divided by 2 is 3. That's a 1. And then it's 1 times 3 is 3, and 1 times 8 is 8. So 3/8. This would represent 3/8. So you'd have like 1, 2, 3. And then every time you have 2 pieces, that'd be 4, 5, 6, 7, 8. And we're talking about 3 of them. Okay, so hopefully you guys can see that. Next one, 1/3 of 4/5. Your vertical model is fifths. 1, 2, 3, 4, 5. Shade 4. And then 1/3, we're going to have 3 pieces this way horizontally. Shade 1. Here's where the answer lives, in the double crisscross. And can we simplify here? 1/3 times 4/5. Sometimes you can, and sometimes you can't. If I was to switch these around, I would not be able to have something even when I divide my fraction. If I don't get an even number, then just go ahead and do your standard multiplication, 1 times 4 and 3 times 5. And this is going to be your simplest form. That's going to be the lowest or most basic answer you can get. I will not be able to reduce it. So 1, 2, 3, 4. Yep, 4 pieces shaded, double shaded, out of a total of 15. And that's all there is there. And on this one, we have 4/5 of 1/3. Notice that it's just the same fraction that I had here, same fractions, but they're switched. So my model looks different because I have 1/3. That's what I have first. Remember, the second fraction is what you have first. So then your model would be fifths horizontally. 1, 2, 3, 4, 5. We're going to shade 4 of them. I think I'm going to have to scooch over because my arm feels awkward. There you go. And so you still have the same number of pieces that are double crisscrossed. Again, rewrite 4/5 times 1/3. And even if I switched them around, I wouldn't get anything different than 4/15. Okay? All right, let's do the word problems. Okay, Sarah has a photography blog. 3/7 of her photos, watch out where the fractions go, remember. Are they going to ask us about the fraction that's in the problem or the fraction that's not in the problem? So be careful. 3/7 of her photos are of nature. 1/4 of the rest are of her friends. What fraction of all of Sarah's photos is of her friends? Support your answer with a model. That means make a little area model here. So first of all, let's look at that denominator. Make a model. And I need 7 pieces. 1, 2, 3, 4, 5, 6, 7. Okay? And before you shade, you may have already shaded. Uh-oh, stop. Okay? Before you shade, you've got to look and see what we're identifying. 3/7 are nature. 3 are nature. Okay? 1/4 of the rest are her friends. 1/4 of the rest. If the rest is over here, and we're going to take 1/4 of that, like in your model, you should be able to see that if there are 4 pieces and we're taking 1/4, what fraction of all the photos are the friends? You can see it right there. I know what the answer is because I can see it in my model. If there were 7 pieces and it's one of them, my answer is 1/7, okay? But I'm going to support with an expression. I'm going to do 1/4 of 4/7. If 3/7 plus 4/7 makes the whole model, 7/7 makes 1, then I'm interested in this section that is the rest, and it's a part of that. So that's where you're getting the numbers, okay? Now you can rewrite it if you want, 1 times 4 over 4 times 7. You can switch those around and have 1/7 times 4 over 4. Either way, the 4 is going to become a big giant 1, and you end up with 1/7, and those would be the photos that are friends. Are photos of friends. Okay, so hopefully you got that and you could see it when we were building our model. Don't forget to click subscribe, that little button that's right there. Right there, so handy, so convenient, so easy. Come back again. Okay, at Lorita's Bakery, 3/5 of the baked goods are pies, and the rest are cakes. So how many are cakes? If it's 2 groups, pies and cakes, and 3/5 are pies, then 2/5 are cakes. So you're building that whole, all the baked goods, okay? 1/3 of the pies are coconut. Oh, hello, lights. 1/6 of the cakes are angel food. What fraction of all the baked goods are coconut pies? So first of all, let's make a little model. If I have, let's say I have a tape diagram, and I go 1, 2, 3, 4, 5, and I have baked goods, 5/5 baked goods. Pies get this section. The rest are cakes. Mathematically speaking, I'm going to go look here and say if 1/3, because we're interested in A, we're looking at coconut pies, 1/3 of the pies are coconut. So I can see one of these pieces, right? So 1/3 of 3/5, because that's the fraction that goes with the pies, that's going to be my coconut pies. Now when you see both 3's, this is going to be something where you could switch using the commutative property. If you wanted to rewrite it, you could 1/3, and then switch those 2 and do 5 times 3. I didn't switch it on the other side, but you can do it here. 3/3 is equal to 1, and then 1 times 1 is 1, and 5 times 1 is 5. And that makes sense because in my tape diagram, I'm showing you, hey, look, if the pies are 3 and we're taking one of them, then it's 1/5 of the total amount of baked goods. What fraction of all the baked goods are coconut pies? 1/5 of all goods, all baked goods, are coconut. Coconut pies. Okay, so there's your answer for A. That's just for fun. Okay, and then for B, what fraction of all the baked goods are angel food cakes? So going back up here to your clue, 1/6 of the cakes. 1/6 of the cakes. What's the fraction for cakes? We determined that up here. Okay, so that's why coming up with these, like making the holes, that's really good to think about as you're going through. If you wanted to rewrite it, and then take a look at this 5 and the 6, knowing that the cross-canceling 2 and 6 are connected, what if you were to switch those around and simplify before you multiply, which I've said so many times, but I'm going to say it again. Simplify before you multiply. How do you do that here? You're going to take your 2 digits in your top bottom. Ignore the 1/5 for now, okay? Take your 2 and your 6, and you're going to find a common divisor, the greatest common divisor that you can. Now, both of them are divisible by 2, so divide by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. That leaves me with 1 times 1 is 1, and 5 times 3 is 15. That is your final answer to what fraction of the baked goods are angel food cakes. Of the baked goods are angel food cakes. Okay, so I hope you see what I'm doing there. Last problem here. Grandpa Mick opened a pint of ice cream. Okay, and just for the record, that's not a lot if he's going to be sharing it. I think I must eat more than your average serving. But if he opens a pint of ice cream and he gave his youngest grandchild 1/5 of the ice cream and his middle grandchild 1/4 of the remaining ice cream, then he gave his oldest grandchild 1/3 of the ice cream that was left after serving the others. Who got the most? How do you know? Draw a picture. Okay, let's make a little tape diagram here. Let's see what is happening with this pint of ice cream. First of all, he gives the youngest 1/5. Let's make fifths. Okay, 1, 2, 3, 4, 5. 1 goes to the youngest. Okay. His middle grandchild gets 1/4. Middle, 1/4 of the remaining. What's remaining? 4/5. So if I have 1/4 of 4/5, then I have my 4 and my 4, which I could cross cancel and turn into 1, and then I get 1/5 of the middle. Then he gave his oldest grandchild 1/3 of the ice cream that was left after serving the others. Oldest. He is getting 1/3 of what? 3/5. So hopefully you're seeing that you can again cross cancel, and the oldest gets 1/5. The oldest, the youngest 1/5, the middle 1/5, the oldest 1/5. Okay, and this is your picture that supports. Now, what fraction of the pint of ice cream will be left if Grandpa Mick serves himself the same amount as the second grandchild? Well, he could serve himself the same amount as any grandchild because they're all getting 1/5. So if Grandpa Mick gets 1/5, then he's getting the same amount, and then there would be this 1/5 left. What fraction will be left if Grandpa Mick serves himself the same? 1/5 will be left. They all got 1/5. So it actually works out real nicely because nobody gets more than anybody else. Yay. So anyway, that is about it for your homework for lesson 14. And I hope this video was helpful, and we'll see you on the next video. Bye for now.